Hello, everyone. Welcome to the beginning of week 6. We made it to May. We got this week and next week yet, and then that's all the new stuff for this school year. So I hope this video it finds you doing well. Basically, like last week, I'm going to split this week's notes up into two videos. Today's video, we're going to be talking about the area of circles and the area of composite figures. Tomorrow's video, we're going to be talking about perimeter in the coordinate plane and area in the coordinate plane. So like shapes if we plot them on a coordinate graph. All right. As I said, I hope you're all doing well, and let's get started on circles. All right. So the top of the circles notes, all right, a lot of it is the same type of vocabulary words that we've been dealing with when we talked about circumference. All right. A circle is just a set of all points that are equal distant or the same distance from a point that's called the center. All right. The radius is the big one today. All right. It's any line segment from the center of the circle to any point on the outside of the circle. All right. A chord, all right, is any line segment that has its endpoints on the outside of the circle. And the diameter, all right, is just a chord that goes through the center. All right. It's equal to 2 times the radius. All right, and the central angle, that's kind of what we talked about before. If you remember when we did arc length, it's just the angle formed by 2 radii of the circle. All right, and notice there's a whole lot more text down there. Basically what it's saying is that a circle is technically not a polygon because it doesn't have straight sides. All right, so when we're looking at the area, it's got to be a little bit different than polygon. So we can't just take base times height or some variation of that for these. All right. But what we can do, all right, and a lot of you may already know the equation is area equals pi times the radius squared. All right. But here's how we actually got that. All right. And what we do is we break the circle up into various pieces. All right. So this one we'd have break it into fourths. So each angle is a number. And then we just alternate sides. So we kind of, instead of making it go around in a circle, we kind of just put them in a straight line, trying to make it go as far left and right as possible. All right? Doesn't look like anything we've seen before. All right? Then we can split it into 8. And notice we're starting to get a little bit more of a polygonish or parallelogram type shape, except for the sides are curved. All right. And then what they do is they keep breaking it down farther than that. All right. So they keep getting more sectors. And as you notice, each one, all right, gets closer and closer to a parallelogram. All right. Now, notice, even this one that's close, if we zoom in really far, it's still curved here. It's not flat. All right. No matter how many we break it down to, if we zoom in close enough, it's always going to be curved. All right. But how we get this is we call it a limit. All right. If you get to pre-calc and calculus, I'll talk about limits a lot more there. All right. But as we get smaller and 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 smaller, or we get an infinite number of sectors or an infinite number of cuts of our circle, we get closer and closer to a straight line. All right, and that's basically what it's doing there. So as this far one is, we would keep going farther and farther and farther, and eventually what we get to is we would get to a parallelogram, or at least one that's close enough that we can use the area of a parallelogram. All right, so the area of a parallelogram is, if we remember from last week, is area equals base times height. All right. As they break that circle up, all right, I'm going to scroll back up for a second. I'm going to use the 4s. All right. Notice this is the radius from the point to the middle part of the side. That's the radius. All right. And the screen part up top is half the circumference. All right. So now we're going to scroll back down here. All right. Our height is still the radius. All right. And this side is half of the circumference. Well, when we talked about circumference, we had two formulas. We either had 2 pi r or pi times the diameter. All right. Since our height's already in radius, I want to use the radius formula. I'm going to use this one. So that is the same thing as 1/2 times 2 pi r, which if we take 1/2 times 2, those cancel, and we're left with pi r for the base. All right. So if we use the area of a parallelogram, because we're close as we make infinitely many cuts, we have pi times r times the height, which is radius, which is pi r squared. All right. So we get pi r squared is our area formula. All right. Once again, from there, it's just plugging in the radius of the circle. All right. So there's our area formula. All right. And from there, it's just plugging it in. So for this first one, the radius is 9. All right. So we plug 9 in for r. 9 squared is 81. And like before, we're not going to multiply by pi. So just 81 pi yards squared is our answer. We're going to leave the pi in our answer. All right. Second one, well, the radius isn't 10 because 10 is the whole thing. So the diameter is 10. All right. So we take 10 divided by 2. Notice that's what they're doing up there. And we get 5. Then pi times 5 squared is just 25 pi. All right. And there you have 2 for you guys to try. All right. Hopefully it isn't that difficult. Just find the radius, plug it in, square it, take pi on the end. You got your area. All right. Now, when we're finding part of a circle, because we might not always have the full circle, we call that the area of a circle sector, or the area of a sector. It's very similar to arc length, where we found the distance around part of the circle rather than the whole circumference. All right. So if you look here, if we have a semicircle, we have half of the area. So we would take 1/2 times pi r squared. Notice our angle here, our central angle is 180 degrees because it's a straight line. All right. Here that angle is 90 over the whole thing, which is 360, which simplifies down to 1/4. All right. Third one, we have 49. 49 over 360 doesn't reduce, so it would just be 49 over 360 times pi r squared, times whatever the area of the whole circle is. All right. And the last one, just no matter what that angle is, that angle divided by 360, multiply it by the area. So the area of a sector is just the central angle divided by 360 times pi r squared, or pi times the radius squared. All right. They got 2 more worked out for you right here. For this first one, central angle is 195. So 195 over 360. Radius is 6. So pi 6 times 6 squared. All right. Then they do the math. All right. And they come out to get 19.5 pi feet squared. Remember, since we're still talking about area, those units need to be squared. All right. For the second one, angle is 30. So 30 over 360. Radius is 12. So pi times 12 squared, or 144. Pi is our whole area. Multiply that by the fraction, which is 30 over 360, which or reduces to 1 over 12. When we simplify that all down, we get 12 pi centimeters squared. All right. Let's do one more. All right. I'm going to do number 4. All right. Notice we want this part the 270 part. All right. So we're going to start with 270 over 360. And then multiply by the area, which is pi times radius squared, in this case 2. All right. And we'll just multiply and reduce that. All right. 270 over 360, that simplifies to 3 over 4, or 0.75, times 2 squared is 4. Then I have the pi. Multiply that out, I get 3 pi centimeters squared, because we're talking about area. All right. On number 5, be careful. Actually, number 5, you are finding this area. The other thing that I do want to note, though, that there is an example here, is if we wanted, let's say, the smaller part, if we wanted the orange part here, we would have to take 360 minus 300 to find that angle there, which is 60. All right. Notice that's not what it asked for. All right. But that's how we would find that if we wanted that part instead of the 300-degree part. All right. So for circles and circle sectors, that's it. You have 4 to try there in that part of the notes. All right. From there, we're going to move on to composite figures. And we kind of talked about this a little bit with perimeter, all right, where we had to add the arc length and the perimeter of just the straight edges, all right. Area is no different, all right. We're going to break it up into whatever shapes that we know that we can handle. So we might try squares, rectangles, triangles, circles, semicircles, trapezoids, parallelograms, regular polygons, whatever that we have that we can break it down and make sense of it. All right. And if you notice, they have 3 that are worked out here. This first one, they split up into a trapezoid and a semicircle. All right. Here's the semicircle part where they do 1/2 pi r squared. They know the radius is 5, so they plug that in and get 12.5 pi for that part. It's just what we just talked about. If we remember, all right, since it's a radius, this side has to be the same thing. That's not showing up well. Hold on. This part has to be the same thing. So that base of the trapezoid is actually 10. So, and if we remember, trapezoid is 1/2 base 1 plus base 2 times the height. So 10 plus 5 times 3 times 1/2, which is what they got there. And when they do that, they get 22.5. Add it together, centimeters squared, because it's area. All right. Second one, they break it up into a square and 3 semicircles. Notice that all the semicircles are the same, so they just multiply it by 3. Well, it's 6, but be careful, because the radius part is half of that, so it's 3. So they 3 times 1/2, 1/2 because it's a semicircle, times pi times 3 squared. So the 3 semicircles are 13.5 pi centimeters squared. A square is just a type of parallelogram, so base times height or side squared, either one. All right, which just equals 6 times 6, or 36. All right. This third one, there's actually split up into 3 parts. We have our semicircle. We have a triangle. And we have a rectangle. All right. This part's 3. All right. The diameter of the semicircle is 4, meaning the radius is 2. So we get 1/2 pi times 2 squared for the semicircle. We get 3 times 4 for the rectangle. And the area of a triangle is 1/2 base times height. So 1/2 height is 4. Base is 3. So 1/2, 3 times 4. When they multiply all that out, we get 2 pi plus 18 centimeters squared. All right, just like when we were talking about perimeter of composite figures, they keep the pi part and the whole number part separate because the pi makes them not like terms. All right, then you got 3 examples on this page. All right, I'll help you get started with number 3. All right, notice for number 3 we got 2 rectangles right here, and they're exactly the same. So I'm just going to do 2 times base times height. All right, then I'm going to add, well, I got a semicircle here, so 1/2 pi r squared, but, all right, the small part down here actually is cut out. So then I need to subtract the area of that smaller semicircle. All right, well, radius of this big one, well, let's do the diameter first. The diameter of the whole thing is 4 plus 4 plus 4, which is 12. So that's radius is 6 for the larger part. For the smaller one, the radius is 2 because it's just 4. All right, so we'd get 1/2 pi times 6 squared minus 1/2 pi times 2 squared. Oh, I should have done this part in blue. Sorry, guys. I'm going to change that real quick for you. All right. For the rectangles, there's 2 identical ones. So 2 times, well, base is 4. The height is 15. All right. When we do our math out here, 4 times 15 is 60, times 2 is 120. All right, the larger semicircle is 1/2 times pi times 6 squared, which was 36, times 1/2 is 18. So plus 18 pi for the large one, minus 1/2 pi times 4, or minus 2 pi. All right. Notice this doesn't combine anything because 120 doesn't have a pi. 18 pi and minus 2 pi are like terms. 18 minus 2 is 16. So we get 120 plus 16 pi centimeters squared. All right. Number 2, your hint. You have a circle or 2 semicircles, however you want to think about that. You have a triangle right in there, and you have a rectangle. All right, number 1, you just have a semicircle and a rectangle. All right. One last thing we're going to talk about real quick is another real life problem that we see rather than things being combined together. All right, is we sometimes see where you want to cover part of a shape but not inside of something. All right, so you'll find the area, the shaded area, but not the cut out part. All right, so for example, in this pentagon, this first one right here, all right, we want to find this part, but nothing inside that square. All right, so they use the area formula for a regular polygon for the pentagon, which is 1/2 times the perimeter times the apothem, or 1/2 times the number of sides times the side length times, excuse me again, times the apothem. All right, and then they subtract the area of the square. All right. And we're going to ignore this part right here. All right. That part accidentally got copied and pasted, I think, from over there. So we're going to work this one out together. We get 1/2 times the perimeter, which would be 12 for one side, times 5. All right. Times the apothem, which is 8 1/3. I want to round that to 8.3. All right. And that's the area of the whole pentagon. Well, now we need to take away the square. The base of the square is 12, times the height of the square is 12. All right. Now we multiply that out. All right. 12 times 5 is 60. Times 1/2 is 30. All right. 8.3 times 30 comes out to be 249, I'm pretty sure. I'm going to double check that on a calculator a second time real quick, so bear with me. All right. So that does come out to be 249. Minus 12 times 12, that's minus 144, right? Which comes out to be 105 units are in inches, so inches squared. All right, so just take the area of that whole pentagon and then subtract out the square. All right. The second one, all right, notice we have a trapezoid as the big shape. All right, and then we cut out a circle. We don't want the circle. All right, area of a trapezoid is 1/2 base 1 plus base 2 times the height. Area minus the area of the circle, which is pi r squared. All right. They probably should have labeled that the height of that trapezoid was 10. I'm assuming they were trying to argue that this is a square. Oh, they know that's a square. We know that's a square because it's a circle. So we know that this part across has to be the same as that part across up there. So that's how we get that the height is 10. All right. The shorter base is 10. The longer base, 10 and 7, is 17 total. So that's where we get the 10 plus 17. When we work out the trapezoid part, we get 135. All right. If we want the radius of that circle, though, we got to cut 10 in half to get 5. So we're subtracting pi times 5 squared, or we're subtracting 25 pi. All right. Now, there's 3 here for you to try. All right. Number 4, we have a regular octagon, and we need to subtract off that trapezoid at the top. Number 5, we have a square that we need to subtract out the circle in the middle. And number 6, we have 2 circles, all right, a bigger circle, and we're cutting out the middle part, kind of like a donut. All right. I hope, as I said at the beginning of this video, I hope you guys are all doing well. Tomorrow's video will be about perimeter and area in the coordinate plane. As always, if you guys have any questions for me, let me know. All right. The notes for this video go very well with the front side of the assignment for this week. All right. Tomorrow's video will cover the second page. All right. Have a good day, everybody, and I hope you're all staying safe and healthy.